Welcome to my channel Electronic Science Tutorial. Today is the 8th class of Operational Amplifier or Op-Amp. Today I will discuss the adder amplifier or the summing amplifier by using an Op-Amp, and from this circuit we can calculate the voltage gain of the adder amplifier circuit. Okay, so without any time waste, let's start our class. So here is the adder or summing amplifier circuit. This is the circuit diagram of adder or summing amplifier circuit by using op-amp. Here we apply one input voltage through a resistor R1. So I1 current will flow from this arm, right? Here next V2 voltage is applied as an input voltage through a resistor R2. That means I2 current will be flow from this arm, right? Next, a series of voltage is applied here. If we applied here, the last voltage we consider here, that is the Vn, and the last resistor that is considered here Rn, which is connect with a series connection with the input voltage, and the current is In. So a series of resistor and the voltage, input voltage, is connected into the inverting terminal. The non-inverting terminal is connected with the ground connection, and the inverting terminal and the output voltage is connected with a feedback resistor, that is RF. So R1 is the input resistor which is connected, one side is this resistor, one side is connected with the input voltage V1 and the other side is connected with the inverting terminal. R2 is the second resistor, one side is connected with the V2 input voltage and the another side is connected with the inverting terminal of the op-amp. And Rn is the last voltage, that is one side is connected of the input voltage Vn and the another side is connected with the inverting terminal of the op-amp. So I1 current is flowing from the first term, in the second term I2 current is flowing, and the last term In current will be flowing. And from the output terminal to the input terminal, that is the inverting terminal, one feedback resistor here we connect, that is RF. Non-inverting terminal is connected with a ground connection. Okay, now how we calculate the adder amplifier circuit, or from this circuit how we calculate the voltage gain. Let's talk about this topic. Okay, so first of all, sum of the currents, that means I1, I2 and In will be equal to I0 if we apply Kirchhoff's current law at the point G, and G point is, we already talk about this topic, that is G point is the node point or the virtual ground point, which is actually not connected but virtually it is connected. When we apply KCL law at a node, the current entered at this node is represented by positive voltage and the current leaving from this node is represented by negative current, right? So I1, I2, In, total current are entering at this point, so these all currents are represented by positive terminal, and I0 is leaving through the node, so it is represented by negative terminal. That means here we can write I1 plus I2 plus dot 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 plus In equal to I0, right? Hope you understand this line. Next line, from Ohm's law, what is the value of current? Current is equal to voltage by resistor. That means I1 current generate from V1 input voltage and in this arm R1 register is used. So here we can write V1 by R1 plus next I2 current is generated from V2 voltage, and in this arm R2 resistor is used. So here we write V2 by R2 plus dot dot Vn by Rn, that is equal to, in this point what is the value? G point value is 0. We already talk about this topic. So 0 minus V0, that means the voltage drop of these 2 point, that is 0 point and the output voltage point, or the virtual ground point, or the output voltage point, and the output voltage point, that means 0 minus V0 divided by RF. That means here we write minus V0 by RF. Next, that means what is the value of V0? V0 equals to minus RF by R1 V1 plus RF by R2 V2 plus dot dot RF by Rn Vn. Okay. If we can consider R1 R2 dot dot Rn equal to the same resistor value. This resistor, if we consider this R1 R2 value is same and this value is R, we consider here, then what is the equation 1? Then what the equation 1 is V0 equal to minus RF by R within bracket V1 plus V2 plus Vn. So this is the equation 2. With R1 equal to R, it reduces to, with RF equal to R, if we consider RF is also equal to R value, then what is the value? Then V0 equal to minus V1 plus V2 plus Vn. So from equation 2, what we will get? We get the addition of total input voltage, and as well as we get the amplification. If we consider RF value is 10 kilo ohm and R value is 1 kilo ohm, then 10 times amplification is also done from equation 2, and also a negative polarity here we saw, because all the voltage is applied at the inverting terminal. So here we get the negative phase. So negative phase is here appear because all the input voltage is applied at the negative terminal or the inverting terminal of the op amp. So here we saw a negative polarity. If RF value is 10 kilo ohm, R value is 1 kilo ohm, then 10 by 1, that means 10, and into V1 plus V2 plus Vn, that means all the input voltage are to be added and it also be amplified. Okay, so RF is controlled which type of gain we need. We need 10 times gain, or we need 4 times gain, or we need 5 times gain. Okay, so according to our requirement we can choose the feedback resistor value. So this is the adder or summing amplifier by using op amp. If RF equal to R, then the equation reduces to minus V1 plus V2 plus dot dot Vn. Then we not get the amplification part, we only get the adder part. Okay, addition of the input voltage part. So in this way we can step by step calculate the voltage gain of an adder or summing amplifier by using an op amp circuit. Okay. Hope you understand this topic. Thank you. If you like, do like, share and subscribe my channel.